By the way, usually we post on the class webpage the lecture slides or notes or something. And I was thinking about that for last time. There wasn't really any sort of product like that to post, except for the tool sprite itself, which you all have along with BYOB. And when you load the tool sprite in its script area, there are a lot of comments about the different tools within the tool sprite. And you should view that documentation as sort of lecture notes for last time. Really. The other thing that there is to help with this week's material is the BYOB tutorials. On the BYOB webpage, byob.berkeley.edu, there are a series of tutorials. Some of them are about higher order functions and about building tools yourself. So the topic of this week is largely covered in those first two BYOB tutorials. The BYOB tutorial number 3 is about recursion, which you already did a while ago. So those are places to go to review, is look at the tool sprite itself and watch the tutorial projects. Okay, here's the agenda. I don't know if we'll get through all of it, but it's sort of most urgent to least urgent. And the first thing I want to make clear is that the higher order functions that we've been looking at, these are custom blocks written in BYOB. They're not BYOB primitives. So just for example, we're going to look at writing higher order functions in a bit, but here's keep. It's not very long. So keep items such that, and then it has a predicate function as input from some list. And it goes through repeat length of list time. So for each item in the input list, if the predicate is true, then add that item to the result list, and finally it reports the result list. So we're not going to go through every detail of this right now because we're missing some pieces. But before I give you the missing pieces, which is item 2 of the agenda, it's important to understand that map and keep and combine are not built in, and in particular, they don't have to be the way they are. You could design your own higher order functions that worked differently. So now we're going to look at what is built in. And remember, we started by taking just an ordinary function block, like, let me take 3 plus 4 here, and the value of 3 plus 4 is 7. But if I put the block around it, so grab the block, what I get is not 7, but rather the 3 plus 4 block. So this is the fundamental tool that allows us to treat a chunk of program, a block, or we'll see in a bit, a script, as a value, as a datum, as something we can manipulate in our program. And I think I told you last time that the block is sort of the scratch name for what in the literature is called lambda. What I think I didn't get around to saying is that if you have the ability to call a block and you have lambda, which creates blocks, those two things by themselves are all you need to carry out any computation. So without having, for example, plus, we can invent plus. We can invent numbers, invent arithmetic, invent true and false, invent things like if, then, else. All of those things we can invent in terms of just the block and the ability to actually call a block that we've written, which is what we're about to see next. You wouldn't want to program that way. You wouldn't want to start with nothing but the block. Having to spend 20 minutes inventing arithmetic before you could do any arithmetic, that would be really annoying. But if instead of writing a computer program, what you're trying to do is prove things about computer programs, then it really is very useful to say, well, this language that really only has one primitive, the block, is equivalent in power to any of the practical languages that people actually use. So if I can prove a theorem about just the block language, then that theorem is true about any other programming language also. So when we do theoretical computer science, it's really useful to have this idea. Okay, so we've taken 3 plus 4 and we've reified it, which is a fancy name for made it a thing, by calling the block. Well, in order to make that really useful, what we need is a way to invert that, to take a block as a value and actually run it, do what it says to do. And I'm going to make the stage smaller so we have room for big lines. In the control menu, you will find call. Call's a reporter. It has one slot, which is a gray oval, and that means it takes a block as its input, a reporter block as its input. So if I say, call the 3 plus 4 block, I get 7. Okay? So call is sort of the inverse of the block. And this is a BYOB primitive. It's built in. And these are the two main things that we added to Scratch, the block and call. Everything else is based on those. Now, the interesting functions have inputs, right? So we really want to take a block like the empty slot plus 4 block. Now, if I just call that, it follows the Scratch convention that an empty slot is treated as 0. But that's not what I want. I want to be able to call it with an input value that I specify. And that's why the call block has this right arrow over here. So now it says call this block with inputs. And now I can put 6 and get 6 plus 4 is 10. Okay? So all of the higher order functions are built in terms of call. So it'll be call the something or other block with inputs, item such and such of the input list. Right? So questions about what call does before we go on? Yes. You mean, what if I do this? Well, that's calling 4, because the value of this thing, by itself is 4, right? It's not the block. It's a number. So I'm trying to call a number with inputs, and the result will be error. Okay, because you can't call a number. You can only call a function. Can you put a list into the inputs? In principle, you can, but in this particular case, the function that we're calling doesn't have lists in its domain. So in this particular block, the blank plus 4 block, the only input that it makes sense to give it is a number. So you're thinking about something like map, where we have a whole list and we want to apply it to each element. But what we're going to have to do is not call once for the whole list. The map function is going to have to call its input function repeatedly. So it's going to do call over and over again, once for each element of the list. We'll show you some code in just a second. Okay, was there a question? Yeah. What makes call different from having the function out on its own? Nothing does. In other words, you're saying, how is this different from just saying 6 plus 4? Nothing does if we give it a constant function. The value of call is that I can make a variable whose value is a function and say, call that. So maybe it's time to actually look at some code. So let's, again, well, no, I'm going to write a function. I'm going to make a block, list, reporter. I'm going to call it simple map, because the real map has a lot of options and bells and whistles, but this is simple map. So it takes a function which is of type reporter, right? These bottom things down here, the next to the last line, are the gray block-shaped inputs. So I want my input to be a reporter. And over list, which will be an input of type list. Okay, so my block looks like this. Simple map function over list. Okay? So I haven't actually built this block yet, but I'm about to. It's going to be a recursion. Should be a recursion? No, I won't do recursively. It's going to be a simple little loop. So I'm going to say script variables result and index. I'm going to set result to, I'm going to call list with no inputs, and that makes an empty list. Okay, so result is an empty list. Everybody with me? Good. And let's set index to 1. And we'll repeat length of list times. Okay, so what I'm going to do is I'm going to go through my input list, boom, 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 adding items to the result list. Each item will be function of an item from the original. So add to result. And now, here's where I get the answer to your question about what good is call. Because I can't just put a little function blob in there. That's just a variable, and I need to actually call it as a function. So I'm going to say call, function with inputs item index number of list. Call the function, give it one input, and that input is a particular item chosen from the list. And then I always forget to do this. This is my favorite bug. No, change index. Hello? By 1. Right, everybody happy? And now I could just drag result down into this report thing, or actually I don't like to do that. I don't like that little report thing. I prefer to use a report block. Oops, not in there. Not in there, out here. Okay? Yes. The question is, shouldn't I start out index at 0 and put the change index by 1 at the beginning of the loop? It doesn't really matter. Yes, you're right that at the end, index is going to be 1 too big. But that's no different from your way, where at the start, index is 1 too small, because it's not under 0, right? Since we're not going to continue the loop beyond that point, we're never going to actually use length plus 1 as an index into the list. Either way is perfectly fine. I do it both ways sometimes. I thought this one would be a little easier to understand. There was another hand up? Yeah. Is it better to do it with a loop or recursively? Interesting question. Right now, given the way BYOB works, it's better to do it with a loop. And that's because recursive functions involving lists in BYOB are way slower than they should be. For reasons having to do with the fact that Scratch was written with the idea that every single calculation you make, you show on the stage. So if you're doing things like constructing a list in a recursive loop, even if that list is not visible on the stage, you're creating new lists all the time, and it's just next year, it'll be just as good to do it recursively. There won't be a better, either way, whatever makes you more comfortable. Some things you kind of have to do recursively. If the thing that you're doing is complicated enough, then you're much better off using recursion to control the complexity for you than trying to keep track of it in your head and build auxiliary data structures to remember where you're up to and things. But for simple things like this, it doesn't matter. Except now it does matter, sadly. Okay, everybody happy with this code? Okay, every hand that's up is a thumbs up, but some hands aren't up. Everybody happy with this code? It's really better if you're not happy if you let me know now. Okay, well, all right, good. Okay, so we made our first higher order function here. So let's try it out. Over okay. There we go. Yes. Okay. So See if we can get these both on screen at the same time. I'm not sure what you want me to do. Do you want me to put the blank plus 4 block in here? Put the function, put the call block? No. I'm sorry. Oh, what if I drag this out here? Mm-hmm. Oh, put the block around here? Oh, I see. Okay. So what you want me to do, I wonder if this works. You want me to do that. And then take this out and put this here. Oops. Here. Okay. The trouble is, the value of this thing is not a function. The value of this is 4. And that's still true even if I put it here. So I'm saying map 4 over this list. When I say the 4 block, because of the function block, that's the 4 block. So let's try it and see what happens. We get an error. Okay. Yeah. I was thinking it might work and we might get the result 444. But apparently you can't even do that. Whoa, look at that. Okay. Hang on a second. Great. Thank you for helping me find a bug by asking that question. And everybody is saying that happens a lot. This is a Bugzilla site. You log in, take a screenshot if you can, say what you did the best you can. You can upload the project if there's a project file, report your bugs. Next year's CS10 students will be very appreciative. Yeah. Okay, good question. So, So in this case, oh, whoa, that's weird. Oh, no, it's not weird. The theory, this is a user interface question. The theory that BYOB has is if you leave slots blank like this, it's going to do the best it can to read your mind and do what you meant. And in order for that to be true, there's two possibilities. If you call it with exactly one input, then it will use that input to fill any number of empty slots. Okay, so if I did the opposite of what you're saying, and I made 2 empty slots here and 1 input, it does 6 plus 6. Okay? The other is if you have exactly as many inputs as slots. So now, if I put 2 slots, 2 inputs, it fills 1 slot with each input in order, left to right. If you do something else, if the number of inputs doesn't match the number of slots and isn't 1, then it gives up. It says, I can't imagine what you could have meant by this. So if you find yourself in a situation where BYOB refuses to read your mind, then what you do is you fall back on, in the block using explicit input names, formal parameters they're called technically. And then let's say I put 3 formal parameters and I add number 1 and number 3, and I could change the names, but the names, these aren't very meaningful anyway. And I call it, now I have to call it with 3 arguments. I get 6 plus 15. Okay, so that's what you do if you're going to have more inputs than slots for some reason. But why would you do that too? It's a kind of weird thing to do. Sorry? Mm-hmm. Well, this is like f of x, y, z. Here. Yeah. That's right. So this says f of x, y, z equals x plus z. Okay? All right, so, we worked really hard at trying to make the user interface such that if you don't think about it very hard, it still does what you meant. So you guys, after you've played with it a bit, you can let us know how well we succeeded. Okay. How are we doing on the agenda? Oh, run and launch. Okay. So far we've been dealing with reporters, with functions. But there are also higher order procedures that aren't functional, like this one. Let's make the stage a little bigger. So for each item of this list, let's do say blank for 1 second. Okay? So that's a simple example of using commands instead of functions in a higher order manner. So you can write, this is a custom block. So besides custom reporters, what we've seen so far, you can make custom commands, including custom C-shaped command blocks, which we think is very, very cool. Well, it's a higher order procedure, actually. It's not a function at all, but it's a procedure that this C-shaped slot is an argument, right, for each. Because we don't just do this beforehand and then go to for each. It's this thing. This thing is a script, implicitly, that for each runs repeatedly. Yeah. Code for each? It's a little tricky because for each takes multiple list inputs, which we haven't talked about yet. But the important part is this run that's sort of pale orange. There's action, which is a C-shaped slot. So if we look at how this was defined, if we look at the long dialogue, the box that's clicked is C-shape for this input. And in the prototype, there's a left square bracket, which is supposed to look like a C without being a letter to confuse you, which is a reminder that it's a C-shaped input and not a sort of inline input. And we can run it, and then how we run it is a little tricky because of multiple input lists, which we'll get to. But for now, just look at run action. That's all you have to look at. Okay? Is that a hand up? Was there another hand up? Okay. So, to make that work, well, two things. First of all, next to the block is this other thing called the script. And there's an implicit the script here. So this thing is the input to for each. It's, again, a lambda, but because Scratch makes a distinction in these shapes between command blocks and reporter blocks, we have to make that distinction also. So there's the block that takes reporter blocks, and there's the script that takes zero or more, it could be empty, command blocks. Okay? So two kinds of lambda, the script and the block. Corresponding to that, we have two kinds of actually run the procedure. This call, which we've been using so far, which call itself is round, it reports a value, and also its input is round. It takes a reporter block as its input. The thing that's used inside for each is run, which takes a script like this as an input. Okay, except again, as in the case of call, you wouldn't really use it with a constant script like this. You usually use run with a variable, and the value of that variable is a script that you got from a higher order procedure. So the input slot here is more or less jigsaw shaped. It's not very pretty, meaning that what goes in here is a command script. There's a variant of run called launch. And this is just for convenience. It's exactly like run, except it starts a new thread so that your script is doing something, boom, 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 launch, and then your script keeps going, and meanwhile, a new thread starts running whatever the script is that is the argument to launch. Input launch, yeah. It's just like the question, why do I need to use call? If what I have is a fixed script, like this, the script here, then yeah, I could just say the say block instead of all this. But usually what I have, let's go back to the definition of for each. I say run a variable. Okay? And the value of that variable will be some script that I want to run. Does that make sense? Yes. In the for each, why don't in here, why don't I say the script action? Because action is already a script. Because when I call for each, it doesn't look like it. You're right. So I see why you're confused. This C-shaped slot is a little tricky. It implicitly wraps a the script around the input. Okay? So, in fact, I think I can actually make it look more like what it really is this way. Okay? Does that help you understand? Yeah, that is... it's easier to understand if you don't think about it too hard. Okay, other things? Well, at first you don't think about it very hard, and you understand it in a way that's good enough to be able to use it. And then you think a little harder and you get all confused. And then you think a little harder again and you say, okay, now I see what's going on here. Yeah. No, not a condition, not a, only do it under these circumstances. I mean, that could be true in a program, but basically you use run, launch, and call. Essentially always, what you give them as inputs is a variable. If you have a variable, you can't just say, without using run, launch, or call, you can't just say run this variable. You can't put it down as if it were jigsaw shaped in the middle of a script. So that's what these things do. They give you a way to take a variable whose value is a block or a script and make them actually run. Does that make sense? Okay. So you can put a fixed block in there, which I've been doing in the course of this lecture. I've done that a bunch of times, like run this thing, or here's one, call this particular block. Okay. But you would never do that in practice other than because you're explaining it to somebody. In practice, 99% of the time, what goes in here is an orange oval. It's a variable whose value is either a script for run or launch or a block for call, or a reporter block. That make sense? So run/launch is the inverse of the script. Call is the inverse of the block. And those things, now we have all we need with the script and call, basically. That's all we need to perform any computation. And again, you wouldn't want to. You wouldn't want to do everything in terms of just those. But if you had to, you could. Okay? Okay, how are we doing on the agenda? Multi-list map. Whoa, we're not going to make it through the agenda, but that's okay. No problem. It's better that you ask questions than not, given... Oh, plus, where the arguments are just stuff, things other than procedures. Yeah. Can you invent for each? Is that what you're asking? For each is a higher. The say isn't part of for each. It's an input to for each. The fact that you can use say as an input to it is what makes it higher order. Yes. Okay. It's not like say is part of for each. You're not looking for it. Okay, so here's the deal. Zero order data is just plain simple stuff like numbers and strings of text and so on, okay? A zero order procedure is a procedure whose inputs and output, if it's a reporter, have to be zero order stuff. So all the functions that you ever heard of before this semester, probably, were zero order functions because their inputs and outputs were numbers, let's say. Okay? First order things are things that refer to zero order things. So a procedure whose inputs are zero order procedure, zero order things is a zero order procedure. A procedure that can take a zero order procedure as input is a first order procedure. A procedure that can take a first order procedure as input is a second order procedure, and so on. But in practice, nobody ever talks about any of those things. It's just sort of ordinary zero order things and higher order things. So once you have the idea of using a procedure as data, it doesn't get any more interesting after that. Okay? But that's where the name comes from. If you want to really prove theorems about it, then you start thinking carefully about first order and second order and so on. Otherwise, you end up with paradoxes, which we're not going to get into because this isn't a recursive function theory class. Okay. Multi-map list. That's where we are. So here's map, and you'll notice it has these little left-right arrows. And that's because that would be a really dumb thing to do, but this isn't. So you can take a 2-input function and map it over 2 different lists that are the same size. So let's go ahead and take the plus block and map it over this list and just to make the arithmetic easy, so we can do it in our heads. Boom. Hello? Thank you. So what we get is 7 plus 40, and then 8 plus 90, and then 1 plus 20. So it goes through the 2 lists element by element in parallel using this 2-input function that I've made. The number of lists has to agree with the number of slots in the function. Yeah. You want number 1, number 3, number 2? Something like that? Then what you have to do is make your block have, yeah. Yeah. Is that hand up? I don't know. Probably an error. Let's find out. Make you happy. No. It took that to be 0. Now, on the other hand, if this one's shorter, we get a different result, I think. We only get 2 results. Because when the first list runs out, that's when it stops. That just happens to be the way map is written. Okay? So map has this feature, and for each has this feature that you can give it more than one list. It's every once in a while useful. If you've done linear algebra, suppose you have 2 vectors and you want their dot product. Right, so you multiply term by term and then you add. So we would use a map with a 2-input function. We would use the times block, and then we would use a combine to do the adding. Right? So it does come up once in a while. It's useful to have around. You'll notice that keep doesn't have any arrows at the right. If you think about it hard, for keep, it only makes sense to have the list that you're applying the predicate to. It's hard to know what it would do with an extra list. I mean, we could invent some things for it to do with it, but basically the natural thing is just to have one input. Oops. And the same is true for combine. Right? Combine really only takes one input list. But map and for each take more than one. Okay, writing a higher order function. Oh, we did that. We wrote map. Okay, good for us. We can now, I showed you, but now we're in a position really to appreciate keep. So have a script variable result, set result to the empty list, set number sign to 0. Now this time I'm doing it your way. Number sign to 0, repeat length of list, change number sign by 1, first thing. And now, this is where it's different from map. Map said, add f of the item to the result list. This says, if, call the predicate with inputs the item. So we take the predicate function, call it with this list item as its input. It reports true or false. If it reports true, then add the item to the result. Not f of the item, just the item. If it doesn't report true, if it reports false, then we don't add it to the result. Okay? Don't forget that you have to change the index variable whether you added it to the result or not. That's a common bug. Okay, skipping ahead because I'm here already. What's the deal on this number sign? So if you look at the actual keep block, there's this number sign variable. And if you remember what that's for, is that we can use it in the function to mean which item number in the list are we up to. So let's say I want to keep every other item from a list. I can say keep items such that equal let's quote this, stick this in here. Keep items such that the number sign mod 2 equals 1. We'll keep the odd numbered items from, now let's make a list. Boom, being the of kite. Okay, so that's how we would use number sign. Yes. Oh, if I left that blank, instead of asking about the position in the list that we're up to, I'd be asking about the value in the list. Okay, here I'm not looking at the values at all to decide. Okay, it's not like, suppose I wanted to keep the words whose length was odd. Then I would have a blank. And I would have, length of blank as something I was looking at. But here, I'm only looking at what position I'm up to. Yes? That's correct. In this case, there are no empty slots in the function. So it's ignoring the input, yeah. Yes. Yeah, so that was what I wanted to get to. I see everybody's muttering because it's time to go. So let me just, hush. Let me say this quickly. This number sign has the form of an input to the keep procedure. It's really not an input. It's more like an output. It's something that the keep procedure makes available for you to use in this script. Okay, and the way that that works is when I made this, so it's input name, so it's just like an input, but in the long dialog, way down at the bottom, it says, make internal variable visible to caller. So it's like saying script variables, number sign, sort of, except that there's that orange blob out there that the user can see. Okay? So that's called an upvar, meaning upward from the keep procedure to whoever's calling it. And that's how you make one. It's a minor little detail, but it's well, it's a good way to, the way it's used is, for example, if you've ever programmed before in another language, you've seen something that looks like this. For I equals 1 to 10, do this, right? So now I want to be able to use this variable in the this, and you do use an upvar for that. Okay? Yeah. Well, it's for use by the argument script. That's all. All right, we seem to be out of time. See you later. It's not global. It only makes sense in the script. You can, by the way, rename it. You can click on it and give it a different name externally, and it's still called I or a number sign or whatever inside the script. It wouldn't have a value, yeah. But see, what I can do is this. I can turn this one into J and have nested for loops, which I think is very, very cool. Yeah. Here. Yeah.
But then you change the value to 0.
At the beginning.
Does that affect what it means outside of it?
Yeah. Here's. So it starts out being 0, and then each time through the loop, it's only when we're doing this call that the value of number sign really matters to anybody outside of the procedure. Inside the procedure, it's like any other local script variable. Outside the procedure, when we're doing a call, the function that we're calling is allowed to use number sign. See, ordinarily, when you have a local variable in a script, and if you call some function or inside your script, the function that you call can't look at your variables, right? It has its own local variables, but it can't see yours. This is a way of making your local variable visible to the outside world. Okay? Yeah. Oh, I'm sorry. No, there's no such thing as by itself. It changes because of that change by 1. Yeah.